Hello everyone. Engineering statistics and linear algebra. We have started linear algebra. In last video we have discussed a definition of a vector, addition of vectors and a multiplication of vectors. Today we do discuss what you mean by the space, what is linear combinations of vectors, what you mean by independent and dependent vectors. All these concepts will be discussed in this video. R, it indicates this, and 2 indicates the dimensions, two-dimensional space. Similarly, R3 indicates space in 3-dimension coordinates. Rn indicates a space in n dimension. Dimensions can be 2, 3, 4, 10, and so on. In that reason, the space is denoted by here R. The term R is used because in that space values are all are real. That's why the number R is used here. So R2 indicates two-dimensional coordinates consist of all the real numbers. Here those two coordinates are X and Y. This is the space here. This is a space. All right. Always vectors are denoted with small letters, arrow mark above the hedge. For example, V with arrow, A with arrow, and so on. Similarly, similar two vectors are considered here. Vector V and vector X all are small letters over which an arrow mark indicates these two are vectors. They are in a two-dimensional space. The meaning of this is belongs to vector v and x belongs to a space with the two. The meaning of it two-dimensional space. Okay, it means vector v and x are in two-dimensional space. All right. So what is the meaning of this R3? R3, a region in a three-dimensional coordinates. Consider the three-dimensional coordinates here. Consider three-dimensional coordinates. In that three axes are available, that x, y, and z. We can observe here vector v and vector x, they are in R3 space in which three-dimensional coordinates x, y, z. The space, the region in this three-dimensional coordinate is called as here the R3. All right. So this R3 can be R4, R5, and so on, Rn. The meaning of it is the real numbers in that region. Real numbers in that regions. All right. What is linear combination? Consider the vectors v1, v2, v3, and so on, vn. All are in Rn space. Meaning of it is all these are our vectors having n dimensions. This n can be 2, 3, 4, and so on till n. If you want to say that the linear combination of all these vectors, if I want to say that All these vectors, they are producing a linear combination result. There should be one condition, that is addition of all the vectors with a scalar gives a linear combination. We have discussed how vectors are added and how vectors are multiplied with the scalar values. This equation is nothing but a linear combinations of a given vectors. Here it is n. All vectors are added along with its scalar value. This equation is nothing but here a linear combinations of a given vectors varying from v1 to vn. They are in Rn space, where c1, c2, c3 and so on cn belong. They are the scalars, they are constant values, and they are present in Rn space. What do you mean by span? A span of a vectors is all the linear combinations of the vectors here. Span of a vector is all linear combinations of the vectors. We have discussed what is linear combinations. Addition along with its scalar value is called as a linear combination. Span of a vector is all possible linear combinations of a given set of vectors here. Let us consider vectors from v1 to vn. All are in space Rn. Then span of a vector is given by span of the vectors from v1 to vn. It is what a linear combinations of a given vectors. It is a linear combinations of a given vector. This RHS gives a linear combinations of a vector. This is nothing but a span of a given vectors v1 to vn, where c1 to cn belongs to Rn space. What do you mean by linearly dependent and independent vectors? Consider a set of vectors. S indicates a set where a number of vectors are available varying from v1 to vn. To say that vectors v1 to vn are dependent each other, following condition should be satisfied. That condition is a linear combinations of the vector should be equals to 0. So can you call LHS side is a linear combinations of a given set of vectors? If it is equals to 0 for some CIs, not all 0, at least one non-zero. If this is the case, then we can say that these v1, v2, v3 and so on, they are dependent each other, else they are independent. So in vector set, a linear combination of some vectors is used to represent any vector of the same set. Then they are dependent, else independent. One more definition for a linearly dependent vectors here. If any one of the vector is used to represent another vector, then those two vectors are dependent each other. For example, consider a vector v1 that is equals to 1, 2. Consider vector 2, 2 and 4. Just by an observation, can I write v2 is equals to 2 into v1? So vector v2 can be represented using v1. If this is the case, means a set of vectors v1 and v2, they are dependent each other. If two vectors are dependent, then they are collinear. Means they do fall in a same line. A collinear means they do fall in a same line. If two vectors are dependent, then one can be represented using another. That is done here. If these two are dependent each other, then one vector is used to represent another vector here. All right. Now, here two vectors are given. R spans or span of S, that is R2 dependent. This is the asked questions here. What they have asked, not only V1 and V2 are dependent. No, they have asked us to calculate first a span of S. Later, that span, are they dependent? That is the question here. What is span? All possible linear combinations of a given vectors. If they are dependent each other, what is the first possibility? One vector can be used to represent another vector. If this is a case, means then we can say that these two vectors are dependent each other. Then you can also say that a rank of a matrix, using a rank of matrix, we can say that the given vectors are dependent or independent. How to calculate rank of a matrix? So consider V1, let us V1 and V2, let us write in a matrix form. Can we write the given two vectors in a matrix form? Yes, they are written here. Then determine its determinant. Determinant of A equals to 2 into 6 minus 3 into 4. That gives a 0 here. If the determinant of a matrix equals to 0, then a rank of a matrix will be lesser than its order. What is order of this given matrix? It is 2 cross 2. Let us calculate its rank. We have calculated it is 0. If the rank of the matrix is lesser than its order, then you can say that the given two vectors are dependent each other. You should keep that point in your mind. If the determinant is not equals to 0, it is some real number, at that point a rank of the matrix will be equals to its order. In this case the rank of the matrix will be less than 2 because the determinant value is equals to 0 here. So this is one method using which we can say that given two vectors are dependent or independent. Okay, let us we calculate uh, one more thing here. Observe v1 and v2. Can we represent v2 in terms of v1 here? Here 2 and 3, 4 and 6. Can I write v2 in terms of v1? That as 2 times of v1 is nothing but v2. If this is the case, then these two are dependent each other, right? So these two methods are used to say that the given two vectors are dependent or independent. Mathematically, let us prove. They have asked a span of a given two vectors. A span of given two vectors is nothing but a linear combinations of the vectors c1 into v1 plus c2 into v2, that is equals to 0. c1 into v1 plus c2 into v2. So 2 times of v1, that is nothing but this v2 that is written here. Take 2 vector 2 3 common. Now it can be written as a c3, one more constant, so that here the vector v1 can be used to represent v2, so that they are dependent each other. They are dependent each other. Vector v1 can be used to represent v2 as v2 equals to 2 times the v1, therefore they are dependent. Already we have discussed. The rank of the matrix is not equals to its order, therefore they are dependent. You can use any one of the method. I have said three methods here. Either we can use rank of the matrix to say the given vectors are dependent or not, or else just by observations is it possible to represent one vector using another vector, and the third method is this one. Okay, so in all these three methods we can say that the given vectors are dependent each other. All right, now second question is vector v1 and v2, 2, 3 and 1, 4 are spans equals to R2 dependent. First find out the span of the given matrix, then are they dependent? Now first method is just observe v1 and v2. Is it possible to represent v1 and v2 in terms of using one vector? No, it is not possible here. Either v1 nor v1 is expressed in terms of v2, neither v1 v2 is expressed in terms of v1. It is not possible, so that we can say that they are independent each other. None of the vectors can be used to represent another here. That's why they are independent. If you are unable to correlate v1 and v2, then you can use another method, find its rank. How to find it out? First represent v1 and v2 in terms of matrix, that is 2, 3, 1, 4. Let us call this as a matrix A. Find its determinant, 2 into 4 minus 3 into 1. It is 8 minus 3. It is not equals to 0. So determinant is not equals to 0 gives a result, a rank of the matrix as its order. Order of matrix is 2 cross 2. Then order of the rank of the matrix is 2. If the rank of the matrix and order of the matrix are equal, then you can say that the given two vectors are independent in nature. Okay, so the rank of the matrix is equals to its order, so that they are independent each other. So take these three problems as assignment. So calculate whether v1 v2 are independent or not, or whether, say that, conclude by yourself whether they are dependent or independent. Okay, next set of problem, v1 v2 v3 are spans are dependent. Here using rank of a matrix it is difficult to find out. Rank of a matrix can be calculated only if uh, number of rows are equals to a number of columns. If these three vectors are represented in vector form, results unequal number of rows and columns here. So using finding a rank of a matrix, you cannot say that the given vectors are dependent or not. All right, the second method is just by an observation. So can you say here vector v3 can be represented in terms of v1 and v2? Is it possible? v1 plus v2 gives v3, is it right? 2 plus 1 equals to 3, 3 plus 4 equals to 7. If that is the case means, so v1 v2 v3 are dependent vectors. All right, one more possibility, we have defined definitions. These vectors are dependent if this condition is satisfied. If this condition is satisfied, a linear combinations of given vectors, if it is equals to 0 for some ci's, not all 0, at least one is non-zero, then you can say that they are dependent each other. Let us apply this rule. Consider C1 V1, C2 V2, C3 V3, and so on. Cn and Cn Vn equals to 0. Here only three vectors are given. C1 into 2 into 1 plus C2 into 3 into 2 plus C3 into 1 into 2, that should be equals to 0 for any values of C1, C2 and C3. All right, let us write equation number 1 in terms of this. Equations can be written as this matrix form can also be written as 2 into C1 plus 3 into C2 plus 1 into C3, that is equals to 0. All the first values are written here. Next, second equation, 1 into C1 plus 2 into C2 plus 3 into C3, that is equals to 0. Using a second row, the second equation is written here. Assume any value of C3. Here I have assumed C3 is equals to -1. It can be any value. It can be any real value. Assume any value of C3. Here the -1 is assumed. So these two equations become 1 into C1 plus 3 into C2 minus 1. Sorry, it is 2. 1 into C1 plus 2 into C2 minus 2, that is equals to 0. Solve these two equations. Solve these two equations. Solving these two equations, we will get C1 is equals to -4, C2 is equals to 3. Use a calculator and solve the values for C1 and C2. As a result, we have calculated C1, C2 and C3. C3 is -1, it is assumed. For that assumption, C1 and C2 are calculated. Put these values in equation number 1. So C1 is -4, -4 into 2 -8, -4 into 1 -4, that is done. C2 is 3, 3 into 3 it is 9, 3 into 2 it is 6. C3 is -1, -1 into -1, -1 into 1 it is -1. Okay, add all these values, so it gives 0. So if this is the case means, the given three vectors are dependent each other. For any values of C1 and C2, for any values of C1, C2, C3, if the LHS equals to RHS, then you can say that the given three vectors are dependent each other. Okay, the key point is assume any value of C3. It can be any real number. Later calculate C1 and C2. Later you can calculate C1 and C2. Then put them in this equation 1. If LHS equals to RHS, then they are dependent each other. Therefore, they are dependent. All right. Here three vectors are given. Then R span, are they dependent? Let us prove it. Observe first. Is it possible to represent any one of the vector in terms of other two? I think it is not possible here. So none of the vectors are used to represent any other vector. By not say that, you cannot say that they are dependent or independent. So that go mathematically. Find out a rank of a matrix. How to find out rank of a matrix here? Represent these three vectors in terms of matrix 1, 1, -1, 2, 2, 1, 3, -1, 0, 2. Obviously, after calculation, it will not be equals to 0. The determinant of A will not be equals to 0. it gives a rank of a matrix as its order. Order is 3 cross 3, then the rank of a matrix is also a 3. If this is the case, means they are independent. This is the first method, you can say. So take all these three vectors, represent them in a matrix form, determine its determinant. In this case, it is not equals to 0. If it is not equals to 0, then rank of the matrix will be its order. It is 3. Then they are independent. This is the first method. We can use the other method. Verify this formula. Span means a linear combinations. If it is equals to 0, then you can say that they are independent. They are dependent, else they are independent. Okay. Substituted v1, v2, v3 in this equation. So first equation is 1 into c1, 2 into c2, minus 1 into c3, that is equals to 0. Second equation is minus 1 into c1, 1 into c2, 0 into c3. Third equation is 2 into c1, 3 into c2, 2 into c3, that is equals to 0. Solve these three equations using calculator. Solve all these three equations using calculator. Then we will get c1 equals to 0, c2 equals to 0, c3 is equals to 0. If this is a case means, they are independent. They are independent. If you put all c1, c2, c3 values, the result is 0. But you can observe here the condition. At least one of the ci should be a non-zero here. But here all these ci's are 0 here. Because of that, it is giving the 0 value, but this condition fails here. So that they are independent each other. Okay, either you can use this method or simply calculate a rank of a matrix. If it is equals to its order, then you can say that it is independent, else they are dependent. Then try these vectors, solve by your own, then comment whether they are dependent or independent. Okay, we see in the next video. Like, share, comment on the video, and don't forget to subscribe the channel. All right, thank you.